Okay, here we have a question about a pulley. I'm going to confess at this stage I think I've gone a bit overboard. Again, not for the first time in this particular paper, I will admit. We're asked to find the ratio of two masses, m1 and m2, and we know that mass 2 accelerates downwards at a rate of g over 2. That's our setup, okay? Suggest you take a second to pause, try the question, and then when you're ready, be ready to look at lots and lots of equations, because I've outdone myself here. Okay, let's go for it. This question is a really great test for your ability to set up free body diagrams and understand kind of what they mean and how we incorporate them into equations. We're going to start with the free body diagram of mass number 2. Now, in this case, we should know that mass number 2 has got a weight, which is acting down, and that's equal to m2 times g. There's also a force acting up on it, which is the tension. We don't know the tension here, and that's key to solving this problem. Now, we can use this to set up a few things. Before we do so, let's just look at the size of those arrows. Why have I drawn them in this way? Well, W2 is bigger than T because this thing is accelerating downwards. Okay, this thing has got an acceleration downwards, which is G over 2. Now, for this initial part of the problem, I am going to just assume that downwards is positive. Okay, and I'm going to set up my equations. I'm firstly going to say that the force on 2, the resultant force, must be equal to the mass of 2 times the acceleration of 2. We know the acceleration of 2 is g over 2. Well, I also know that the net force on this thing has got to be the weight, which is acting downwards, take away the tension, which is m2g minus t. Okay, and then what I can do is I can take those two equations on the screen and put them back together to show that actually the tension is equal to half of the weight. Okay, the tension is equal to half of the weight of object number 2. I put that in red because we're going to use this value later. Hopefully you followed so far. We've not answered the question, and we're only halfway. The second half involves thinking about the other mass. Okay, mass number 1, well, in this case, we've got the tension, we've got the weight acting down. This time the weight's very small because this object is accelerating upwards. Why is it accelerating upwards? Well, because it's got a tension acting on it, which is bigger than the weight. I'm now going to switch my perspective. I'm going to say, actually, now, well, everything going up is positive. That's fine because I'm separating the problems out, and I'm going to be really careful with the directions and the values and the plus and minus signs. Okay, if object 2 is accelerating downwards at g over 2, then that must mean that object 1 is accelerating upwards at g over 2. So we can do the same treatment. We can remember to say that the net force on object 1 is simply its mass times its acceleration, and this time we're accelerating upwards at g over 2. Again, we're going to think about forces. Well, the net force is going to be the difference between that tension and the weight, and that tension is T minus W1, T minus M1 times G. Okay, now that tension is the thing that we've calculated already. So that value is one that we can incorporate into here, and we'll be able to get our ratio from here. We'll start off by simply subbing in the value of the tension and equating our F1 equal to MA, which is M1G over 2. You'll notice we've got half of M1G on the left-hand side, and we've got a minus m1g on the other side. So I'm just going to bring them over onto the same side. So we'll end up with 3 over 2 m1g is equal to m2g over 2. And we've got common factors of g and 2, which are going to cancel and allow us to find that m1 over m2 is equal to 1 over 3. Okay, I told you there's a lot going on here. This is a very complicated problem if you want to do it properly. Now, I would say that if you're doing a problem like this and you find you're going to go down a bit of a rabbit warren of kind of various equations and you're not really knowing what's going on, it's a good idea to use a bit of intuition, okay? There's definitely a way of making an informed guess in this problem, and that is to think about, well, if mass 2 is accelerating downwards, then it must have a greater mass than mass 1, because we know that from our everyday experiences, we know that those weights are going to outbalance each other. Okay, so if you're really not sure what to do here, make an informed guess. You can rule out options 2 and 3, options C and D, because those are suggesting that the mass 1 is bigger than mass 2, and just from our everyday experience, that doesn't make sense. If you want to get to A, you have to do a bit of work setting up these problems, and it's a really, as I say, it's a really big challenge. Again, as I've done with previous problems, if you've got a simpler way of doing this, feel free to let me know. This is the way that comes to my mind, and it works for me, but it may not work for you. So absolutely happy to hear any suggestions on that front. Okay, thanks for watching as ever.